everybody. Welcome back to the Engine Performance Expo. Again, I'm Lake Speed Jr.
And I'm Dyno Mac Askill from Shaver Racing Engines.
And what are we going to call this segment, Don?
Well, this is going to be kind of a fun segment. This is going to be for all the gurus who really are into the nuts and bolts of actually what happens when you get a motor and you take it to the dyno and actually have to put it on the dyno, install it on the dyno, and then run the engine, and then what we actually do after we get done running the engine, because that's just as important as the setup procedures themselves. So I'm going to be running through that whole process here in a little bit. But first, we gave you guys a little tease of one of the things that we were going to test yesterday, and we're actually going to do that today. We talked a little bit about what happens, or that there could be possibly a problem if you're going a little too fast putting oil in your motor and you get a little too much in there. Overfill. That's why it's very important to be patient when you're putting the oil in the motor, especially if you've got a motor that you don't know exactly how much oil goes in it. So this is going to be kind of a fun test. We're going to go ahead and start this motor back up again and get a few more baselines like we did yesterday, so we can get some good numbers. And then we are going to overfill the engine slightly. And when I say slightly, this particular wet sump motor here holds about 5.5 quarts of oil with the oil.
5.5 is our normal level.
What we're going to do is we're only going to overfill this engine by about a quart. About a quart is all. And then we're going to show you on the dyno with the numbers that we get after running that engine slightly overfilled, what actually happens to the horsepower and torque. Okay, now we're back here. We've got the motor fired up and we've got the motor up to temperature. And one of the things that we're going to do here is we're going to make a couple of passes here. We're going to make 3 successive passes. And then after that, we're going to go ahead and do the overfill and see how much difference we actually got. So I'm going to go ahead and make 3 successive passes because the motor is ready to go right now. Again, it's not going to be that hard. 3,000 to 6,000 RPM. We come over here. There's our first pass right there. F12, is it F12 you said?
Hey, Travis,
I'm going to go ahead and make the second pass. Water and oil temper coming up a bit, but we're going to go ahead and make that third pass right now. Okay, now those 3 passes right there, that will help establish our baseline. So we're going to go ahead and shut the motor off right now. We're going to look at some of the data and get it organized, and then we'll be back in just a second. Well, we're back here, and we're very lucky to have Travis Thurkittle here from Superflow Dynos. We really appreciate your time coming out here, and he's going to help us with this whole segment, not only to try to help explain to some of you guys what we're actually, or how the dyno actually functions and how it works, but he's actually because he actually knows how to run this dyno better than both Lake and I put together. He's actually shown us a few tricks to do along with that too. But because we've made such a big deal about how good this Superflow dyno works, and one of the examples of that is in the 3 dyno pulls that we just made, the 3 baseline pulls that we just made. If you look at this screen right here, those are all 3 runs. All 3 of those runs, those dyno pulls, are on the same, basically on the same line. That's how accurate this dyno is. So now that we've got that baseline, and Travis is here to make sure that we don't mess anything up. Thank you again, Travis. Lake has gone in there while Travis and I were talking about some of the nuts and bolts thing, and he's overfilled that crankcase just a little bit. So now we're going to do the same thing. We're going to get the motor back up to operating temperature, and we're going to make 3 more passes and then look at the difference in the data. We're going to do that right now. coming back over here, and I'm looking at the first of the 3 runs that I just made, and I was at about 240 on the oil pressure, and so we're almost there again. So we're really close to being able to make those 3 runs. There's 240. Water temp's a little cool, but we're gonna go. It's warming right up, so we're gonna go ahead right now and then make 3 successive pulls with the engine overfilled just slightly. First pull. Last pull. Okay, there we go. Now that we've made those pulls, I'm going to go ahead and shut this off here, bring the load way up, shut the motor off. Now I'm going to ask Travis to step in because he's so good at this. We have made 6 pulls, Dyno pulls. So what we're going to do is we're going to average the first 3 pulls with the oil level, with the correct oil level, and then I'm going to have Travis average the second 3 pulls, and then we're going to compare those 2 graphs. Travis, can you sit down and do that for me? Sure. And there you have it. That's what happens, folks, when you mess up a little bit and put too much oil in the engine. And what's happening there, obviously we've lost torque and horsepower. And the reason that happens is, on a normal running engine, the crankshaft and the rods are spinning really, really fast, and they're spraying their own oil everywhere. They're shedding oil. The oil's cooling the motor and it's lubricating. But when you get the engine oil level a little bit too high, that crankshaft dips down into that oil sump on a wet sump engine, and it slows the crank down. And this is proof of it right here. That, folks, is why you don't want to overfill your engine.
It's worth pointing out, Don, that it's even easier to overfill an engine when it's a stroker engine, because a lot of times you're using a stock oil pan with a stroker engine, which means the oil level would be different for a stroker than a stock stroke engine.
Because of the fact that that crankshaft is coming down closer to the oil. That's correct.
Exactly. Okay, so let's peek at the other channel. So, Travis, we can look at more than just torque and horsepower.
Absolutely.
So let's look and see what other changes may have happened by this overfill.
So I imagine you'd see a difference in oil temperature. As you have more windage, you're going to be 8-beating that oil, and we see a difference in temperature there.
There's a slight difference, and one of the other things, if we can put on the same screen, is the oil pressure. We have seen before that because we are working with a crankshaft that's hitting the oil, it does foam the oil, like Travis just said, and it will change the oil. It'll start aerating the oil, and the oil pressure will actually come down.
All right, so here's your oil pressure. So let's change the channel to
oil pressure averages. Now that looks like a tremendous drop, but realistically, let's just pick a point here. Let's pick the end point and see what that difference is right there. About 70 psi right there, and right there we've dropped down to, looks like about 60, almost 63. So we've actually, that's how much oil pressure. And as you can tell, as the RPM is coming up, the oil pressure is coming down. That's because the whipping action, the foaming action of the oil is getting greater. And when that happens, the oil pump that's sitting on the bottom of the oil pan, the pickup, is not just picking up oil anymore, it's picking up air. And air is not very good when you're trying to oil down an engine. So that's also one of the negative parts of putting too much oil in your motor. the crankshaft foams the oil, and the oil pressure will decrease, and serious engine damage could possibly happen because of that. I'm getting ready to do the post inspection process right here, but as Travis pointed out, we just made 6 consecutive dyno pulls, 1 with the regular oil level, 1 with the oil level too full, and you guys have now seen what happens when you fill your engine up too high. We were talking about the 3 consecutive dyno pulls for each little segment there and how close they are, and Travis had a very good point. You know, the dyno itself is a really good dyno, but he made a good point that I just kind of take for granted. I'm going to have him talk a little bit about that too.
Yeah, repeatability is twofold. You know, the dyno has to repeat, but it's junk in, junk out. And one of the successes of this operation here is their test cell design has excellent airflow. We have air coming in from the ceiling.
65,000 cubic feet coming in and 35,000 cubic feet going out.
And right out there, exhaust chimney coming across the motor. This way ensures the intake is getting fresh air without a variable there that would affect the repeatability and accuracy of this dyno cell.
That's one of the reasons why we've been so successful in doing the testing that Lake and I have done. Not only the testing that Lake and I have done, but with the sprint car program that we've been working on, that I've been working on for the last 24 years, and the 13 championships that Ron Shaver's had, 10 since I've been here. So it's really been a fun ride. Dyno Don back here again. We just got done doing a fun test, and now we're going to do a little short segment that I call the actual nuts and bolts of dyno operation. And what I mean by that is we're going to talk about, first of all, we're going to talk about the actual setup procedure of what happens before the motor ever makes it to the dyno room. And basically, an engine needs 4 things. It needs water, it needs oil, it needs fuel, and it needs electricity, i.e. some sort of ignition to make everything work. So one of the first things, and I do this the same every single time, not only do I do the setup procedure the same, but when I'm taking the motor off, I do the setup procedure backwards. And because I've done thousands and thousands of motors, it just makes life a little easier, and it makes the possibility of forgetting a step a little less likely. So what do I mean by that? Well, obviously you need to pump water through the motor. So I'm hooking water hoses up to the motor. This is a very simple engine compared to like one of the sprint car motors that we use. And I'll explain the differences in that in just a little bit. But I want to make sure that the water hoses are hooked up correctly, and I didn't leave anything loose. And then I'll go ahead and put water in the motor before I actually move on to my next step. Why do I do that? Well, occasionally you'll put water in the motor and then you go through all the other steps and you get ready to fire up, and then you put the water in the motor and you find out there's a leak. So if there's a leak or a problem, I want to make sure that I can take care of that before I continue. Sometimes that leak's not fixable, so that's why I do it before I do the other steps. So step number 1 is the water. Step number 2 is oil. Well, obviously you need to make sure that the oil is in the engine. This particular engine, again, small block Chevrolet wet sump motor, very simple. You just put oil in it, but I have to make sure that the oil, if it's got an oil cooler on it, I'll make sure the lines are nice and tight. Oil pressure gauge is hooked up, and trust me, the oil pressure gauge hookup could be an issue. There have been a few times throughout my 24 years when I've started the motor up and either got the ceiling wet with oil, which is clean now, or the door over there, depending on which way that fitting was pointed in that direction. So I always check and make sure that that's done first.
Make sure the oil filter's on too.
Man, oil filter's got to be on. I think maybe Lake has done that once or twice. Not fired it up, but we've caught it beforehand. But it's really easy to do when you're doing all the testing that we have actually done. So make sure that the oil system's correct. Step number 2. Step number 3, fuel. You know, on this motor, very simple. You got a simple carburetor. You got to make sure the fuel line's hooked up. You got to make sure that the fuel requirements for the carburetor are correct. Some carburetors require different fuel pressures. All the way, if you got a Holley carburetor, for example, a basic Holley carburetor, you know, somewhere between 6 and 7 psi is fine. One of these Edelbrock carburetors, I normally run between 4.5 and 5 psi. If you're working on like a Weber system like that, you need to run about 3 psi, or else the needle and seat won't function correctly. So You hook your fuel lines up, you make sure your pressure's okay, and then you make sure that there's no leaks. I can go ahead and turn it. All my motors are basically all these factory type motors. I've got a built-in fuel pump and with a regulator that I can adjust. So I'll do that and make sure that the fuel system is correct. Electricity. This particular motor's got an MSD distributor on it, and when I say electricity, we have to hook up an MST box to it to make it work. Now, some of you may have seen that I've got this Dyno box over here, and it's really old. It's been around forever, but that box I've had about 1,500 horsepower on, and I have to hook that up and make sure it's hooked up correctly to the system, make sure your power is hooked up, make sure the wires to the distributor are hooked up, make sure all that's hooked up. So you've got, just to recap, you've got water, oil, fuel, and electricity in that order. Once all 4 of those are done, then you're basically ready to run this engine after you put your exhaust system on and make sure and double check everything you're done. It's very important because, again, thousands of motors later, even I still sometimes make a mistake. But if you do those 4 procedures the same way every time, it helps eliminate some of those mistakes. Now, that's the setup procedure. So the post-test inspection of the engine is very, very critical. And when I say that, what I mean is a lot of guys around the country, even some of the really high engine builders, they'll run an engine on the dyno and they say, "Oh God, it's great. Take it off the dyno and hand it to the customer." Well, you know, most of the time you can get away with that. We have found here at Shavers that we're just not that good. We can't really get away with that all the time. And one of the reasons why we've had such good success over the years, for example, our World of Outlaws program. Lake had earlier mentioned that since I've been here, we've gotten 10 World of Outlaw championships. Well, one of the reasons why that has happened is because of our post-test inspection. We will actually, as you can see here, we will actually pull the valve covers off, pull the exhaust off, and there's a number of tests that we'll do on the engine after we get done running it to make sure that we haven't hurt the engine during our test. Now this little girl here, it's really hard to hurt this one, but when you're working on a 950 horsepower sprint car, it takes about 4 seconds to burn a piston out of one of those motors. So how do we test all of that? Well, this is how and I'm just going to go over this kind of quickly because there's many things that I do, but I'm just going to kind of give you an overview of what I do. So I've got the exhaust system off of the engine here. I've got the valve covers off, and on this particular motor. If I was working on a sprint car, I would be looking at the fuel system too that's on top of the motor because it's a little bit different than this. So, and also too, this is a good thing. Lake and I were laughing yesterday because we were setting up some of the tools that I use, and Lake's going to pan back over here. We were setting up some of the tools that I use for post-race, post-dyno inspection. And he noticed the tape. He's like, "Well, what do you do with the tape?" And I'm like, "Well, that's part of the deal. It's not just, I just don't tape the ports up and tape the carburetor up when I get done. This is actually part of the inspection process, and I'll explain why in just a second." Some of the other tools that we use here, and this tool is basically a big giant pipe cutter that we use for cutting open the oil filters. Now, especially on a wet sump motor like this, after we run the engine, I want to see if there's something going on inside the motor that I didn't know about by looking at my computer screen. And I do that by actually looking at the oil and looking at the oil filter itself. So I'll go ahead and cut the top of this oil filter off, take it apart, and it's with our little tool here that Ron made many years ago. It's really easy to do, and I can cut the filter apart and I can look at inside the filter and see if there's any debris. Now we mostly use this Napa Gold filter on just about anything. Why? Well, it's not a Napa Gold filter; it's a Wix filter. That's one of the best filters that we have. Why do we use this particular filter? Well, there's good reasons behind that too. There's no bypass in this filter. There's no valve inside this filter so that when the filter gets clogged, it bypasses the filter. When I'm running a motor on the dyno, or we're running a race motor, I don't want any oil going past the filter. I want every drop of oil being filtered. if the filter is slowing the oil down, it's time for a new filter. So, and I tell all my customers that. Change the oil filter regularly and cut it open. This is part of the test procedure that the guys will actually do at the racetrack. Now let's go back to the tape for a second. Why do I use the tape? Blake asked me, and I said, okay, this is what we do here. So when I'm going through and I've adjusted my valves, we've got some special tools to adjust the valves. On this particular engine, I don't use these because this has got a hydraulic camshaft in it. But on a solid roller cam, these are the tools that I use to adjust the valve. Very simple thing. So why do I have the tape on that port right there? And many people have asked me that question. Why, when I'm starting this process of leaking the engine down, actually I'll put air in all 8 cylinders, do a leak down test to make sure that the cylinder bores, piston rings, everything is still functioning correctly. So Lake says, well, why is that tape there? Okay. The explanation is actually pretty simple and it's pretty cool. On a Chevrolet, this is a Chevrolet motor, because of the configuration of the valves, the 2 exhaust valves are right next to each other in the center of the cylinder head, which means that the area next to those valves is one of the hottest spots in the cylinder head. What happens when the cylinder head gets that hot? Well, some of you might know this already. Some of you may be fighting heating problems and you might not understand why. You know the radiator is good, you know the water pump's good. This could be part of the problem. On a regular stock Chevrolet, not one of our sprint cars, because we're reverse cooling our sprint car motors. In other words, we're putting the cool water in here first because we know that's the hottest spot. On a regular motor with a regular type of gasket, with the old Felpro blue gaskets or whatever, we used to lose the head gasket right in between those 2 cylinders because that was the hottest part of the motor. And then we'd have to, on the dyno, we'd have to pull the heads off, redo the head, put some new gaskets on it. It was a pain in the butt. Well, how do you know that that's happening when the engine's running good? This is how you know. And this is why I will always put a piece of tape on Chevrolet. This is the number 4 exhaust port right here. This is the number 6 exhaust port. Because of the firing order of a stock Chevrolet, when number 6 is at TDC, number 4, the intake valve is closed, the exhaust valve is open. So you say, why? What does that mean? Well, what that means is if that gasket is blown and the head surface right in between those 2 cylinders, which is where it goes, if that gasket is blown right there, the air will leak. When I put air in number 6 cylinder, it will leak from here to here, over here, into this cylinder here. And the only way, in this configuration, the only way for that air that's leaking out to get out of the engine is through that exhaust valve. Well, you say, well, how are you going to know it's coming out? It's real simple. I'll put air in this hose right here, and I'll put my finger over the spark plug hole. And if it's leaking in between those 2 cylinders, it'll pump that tape right out. Now, so many guys I've told that to, have saved their engines, have been able to fix their motors before they had a catastrophic problem of when the head gasket actually disintegrates right there, it usually takes the head and the block with it. If you do this check after every race or after every dyno pull, or not every dyno pull, but after every dyno session, you can help ensure that you don't have a head gasket issue. Now again, with the development of the new head gaskets these days, the MLS, multi-layer steel gaskets, we use Kinetic, we've used Felpro too, but Kinetic is mainly our main supplier, which we've had very good luck with. The gasket works so well that that's not as big of a problem as it used to be. And again, on our Chevrolet sprint car motors, and I say that because now we're building Fords also, the Chevrolets don't have as big a problem as they used to because we're actually, instead of putting water in the front of the motor, like a normal Chevrolet is, we're putting water directly underneath, right, pointing at those 2 exhaust valves, and we're cooling that part of the motor first. We're letting the water spread out into the cylinder head, go back down into the block, and then we're taking it out of the block instead of putting it in the block right there. So that was the answer to Lake's reason as to why we actually use the tape on the exhaust ports. Now, one of the other tools that we have, and Lake's going to pan back over here, is a borescope. What do we do with a borescope? Well, that's pretty simple. And this one here I actually recommend this borescope here because it's cheap. It was like $35 from Amazon or whatever. And sometimes when we're working on a sprint car engine that's making 950 horsepower, like I said, if we screw up, we put 1 degree too much timing, not enough fuel, whatever, we will start to develop a problem with the piston. The piston will actually start to melt. And literally when that piston starts to melt, it only takes 4 or 5 seconds for it to be totally gone and destroy the motor. So if we have any issue at all, or we want to make sure that after our dyno pulls on one of those 950 horsepower motors that everything's okay, I'll take that borescope and I'll shove it down the spark plug hole and I'll be able to see the majority of the piston and make sure that everything's okay there. That's a very, very important tool. I showed you the stethoscope the other day. That's fairly self-explanatory. This also is a very, very important tool. And there's different kinds here. This tool here is basically a measuring device to measure the pressure on the valve springs. It fits over the rocker arm, pull it, and it will actually tell you how much pressure is on the seat on the valve spring. And you know, you're going to get some differences here and there, but basically I'm using this tool here, especially on the high performance stuff, to ensure that my springs, when I'm testing the spring, that I don't have one that's starting to break or one that got weak during the testing or whatever. Again, as you can see, this one I got about 115 pounds on the seat right here. Some of our sprint car stuff will go up to 300 pounds on the seat, and that's a lot. So if the engine requires a very stiff valve spring and it develops a problem on the dyno, even though you can't see a broken spring, this device will let me know if it's okay or not. Now, one of the last things that I do is the oil. And Lake and I have talked about this 100 times. I just talked about cutting the oil filter open. It's a very simple process, which I'll do right now. Again, if anybody has ever done any pipe work, it's basically a pipe cutter for oil filters, okay? So we're going to cut the lid off of this thing here. Eventually. And of course, the only one that works good is the one that says Shaver on it. We're going to take the lid. This filter, by the way, this here is basically a check valve. There's two numbers to this Chevrolet filter, a 1060 and a 1061. The 1061 does not have, the only difference is the 1061 doesn't have this. Why do I use this right here? It's very simple. If you've got an engine, like our sprint car motors, where the filter's on sideways, the oil can drain back into the engine when the engine shuts off. That's what that check valve's for. So most of the filters we get have this check valve there. Does it hurt if you put one on an engine where the oil's like this, the oil filter's like this? No, it doesn't. But when I say we cut the filter open, this is what the filter looks like from the engine that we just ran. Now, on a brand new motor, or a brand new rebuild, you're always going to see a little tiny something in there. A little tiny something. It's going to happen. But as you can see here, there's really not a whole lot of stuff. So I'm looking at that, and I'm also looking at the bottom of the can, because this filter was on like this. I'm looking at the bottom of the can. Is there any debris, metal debris in there? Well, you know, there's little tiny specks. That's something that will happen every single time you rebuild the motor. It's a matter of how many specks that are in there that's important. And what a lot of folks didn't know either, this is the spring that holds this filter up against the lid. If you ever take a compass, you'll find out that that spring is magnetized. They do it on purpose. Just some little tidbit that you should know. Now, the other very important thing about the oil is, okay, I'm done with the engine. I've got good break-in oil, but I still want to run that break-in oil a little bit longer. Most of the time, when I get done with an engine, you don't have to. So I tell people that. Biggest problem you could have with the oil that you've just dynoed is on a fresh motor. That is the dirtiest that oil will ever be, unless something starts coming apart. The oil that you break in a motor with will be the dirtiest oil that motor will ever see. So please dump it out when you get done. Even if you want to put some more break-in oil in, that's fine. Put fresh oil, fresh filter on after your first dyno session. Very, very critical. Thanks again. Part of the process of the final checkout process is doing the leak down, and I touched on that just a second ago, but I want to actually show how that actually works. This is the basic leak down gauge that we've used. We've used it forever. And if you can actually see that gauge, you can see that my needle is pointing at 80, and most people are going to say, well, why do you have that leak down gauge set at 80 and not 100? Normally, if the gauge is at 100, you have, and then you leak an engine down and it says 90, that's 10%. Exactly. So is it, when you set it at 80 and it goes to 70, is that 10%? No, but you can do the math. The answer is very simple. Ron Shaver wants it that way. Now, why does he want it that way? Because when the guys are doing this in the field, sometimes they don't have 100 psi of air pressure. It's that simple. So over the years, and this started well before I got here, every leak down gauge that is set here in the shop, we set at 80 psi. Because that's what we tell our customers to do. Because in the field, sometimes they don't have 100 psi of air. So we set it at 80. And you're just getting a relationship of the leak down versus the air pressure that you're putting in the engine anyway. So it doesn't really, the math really doesn't matter. It's showing you if there's a problem. That's what really matters. And the simple part about this, which I've already hooked up, is we got the hose hooked up. We're leaking down number 6 cylinder here. And so right now our gauge says 80, and I hook it up, and the gauge, right now it says 74. So approximately 6 psi off of the set part. So go ahead and do the math if you want. Between 76 and 80, you know, it's not 6%. It's probably 7%. But and this is, you got to remember, this is the gas ported ring. So as I'm putting air in this cylinder, it's actually helping to expand that ring against the cylinder wall. When we have a set of rings such as in here that are not a gapless ring, which is what the rings are in here, you know, the average leak down on a gasoline engine will be, you know, anywhere from 6 to 12%. 12%, 14%. It's still not that bad, as long as you're making sure it's not coming from a valve or something like that. But 6% on a non-gapless ring is pretty darn good. And again, as I'm doing the leak down, we go back to the tape to check the head gasket, and boom, if you're looking at that tape, there's no puffiness on that tape at all, which means,
wow, Lake. It's been a really fun 3 days.
It's been a lot of fun these last couple of days doing the testing. And Don, you made a really good point there at the very end of your post-dyno diagnostics, talking about the oil and how that braking oil, while it's a great oil, is the dirtiest that oil will ever be.
Exactly. And
there's a piece of data, because like you said, you know I love the data.
Of course you do.
You can extract some data that's very useful from that used oil. By taking a sample, used oil analysis, it can tell you all the wear metals in the oil. And as you are maybe wondering, well, you know it's dirty and it's very high wear metals. And that's exactly the point. That's the most wear your engine should ever see. Essentially, it's the high water mark. So by taking a sample of that used oil, having it analyzed, now you know what's the highest wear you should ever see. You should only see less than that. Because most oil analysis labs aren't going to be able to tell you the exact, what's the right level of wear for your engine. They're using a generic standard to do that. If you've got a sample of the used oil from your engine, then you can do used oil analysis later in the life of the motor to know how the engine's wearing and performing. If it's ever anywhere close to that used oil sample from break-in, you know you got a problem.
Could be an issue.
Exactly. So again, hopefully all this testing, all the dyno demonstrations and the tool demos have been very useful for you. We appreciate your time. We're going to throw it back to Joe Costello now, because again, this is November, and this is, when you're watching this, it's going to be January or some date in the future. So we'll throw it back to Joe for the question and answer session. Again, thanks for watching.
It's been fun. Thanks, guys.
Welcome back to the Engine Performance Expo. So yeah, Don, Lake, we're back here at the dyno cell control panel. So Don, this section, we're going to talk about dyno tools, tips, tricks. Now later on, we're going to be joined by our buddy Travis Thurkettle from Superflow to talk more about how we use my favorite thing, the software, to analyze the data. right? But so Travis is going to handle that. So you being the master, the sage of the dyno, tell them a little bit about how you go about running the dyno and just the advice you would give to the dyno operator of the future.
Well, you got to remember that this morning at about 6:30, this was a bare block, and at 1 o'clock right now in the afternoon, the motor is actually running on the dyno thanks to the guys here at Shaver. They did a great job for us, and of course, with this Superflow dyno, that makes life a little bit easier for us. So, as you can see right behind my head here, right in between Lake and I, that's one of the dyno screens that I'm actually looking at. So we've actually started the motor up, and as far as some of the tools that, again, we talk about dyno tools, and literally they've made this piece of equipment so easy to run that, you know, it's almost anybody can run, even my buddy Lake here, who is actually one of the only other guys that I will let run this dyno.
I can touch the button.
But so basically what we've done is we talked earlier about the parameters that we want to set the motor at when we first fire it up. The motor right now is in break-in. We are in the break-in mode of this motor, so we're going through our half-hour break-in procedure. And if you can look behind me a little bit right there, you can actually see on the screen that right now we're running at about little over 3,000 RPM, and our load here is about 80 pounds of load. That's the amount of force, about 80 foot-pounds of load that the motor's putting out right now. And with that amount of load, we're actually putting some pressure on the rings, trying to get these new rings, this new ring package, bedded into the cylinder walls themselves. Of course, part of that whole process started with, as we talked about earlier, with the correct oil. We've got our VR40 in there, and right now the computer and the dyno operators here are making sure that all the parameters, the break-in parameters, are correct.
So we actually have a video on correct break-in procedure that Don and I did back earlier this year.
Yes.
It's on YouTube. We'll leave a link below. That way you can find that video to watch that specific procedure for breaking in an engine, because that's what we're doing right now. All the details of that procedure are in that video. So there's another dyno tip for you right there. So again, Travis is going to come tomorrow and be able to film through the software part. Now we're doing the break-in procedure. Is there anything else we want to touch on now in terms of how we apply that thought process to what we're going to be doing today?
Actually, yes. You know, we've kind of skimmed over the break-in procedure, you know, for a number of reasons, but it's actually very important. And when Lake came to me quite a while ago and say, well, how do you do things? How do you properly break in a motor? Well, here at Shavers, we've been basically using the same procedure for the 24 years that I've been here. We vary slightly because you break in a 450 horsepower small block Chevy a little bit different than you break in a 950 horsepower Ford sprint car motor. So there are some differences, but basically you have to do the same things when you're breaking in the motor. And by that I mean, for example, on a motor that's got a flat tap camshaft, you have to make sure that you're not going to kill that cam when you first fire the engine up. That's very critical. On a sprint car motor, basically what you're worrying about is the rings, because everything else has roller bearings. It's roller cam, roller, everything is roller. So, but the problem is when we're breaking in a sprint car motor, for example, we're using methanol, we're not using gasoline, and it takes a slightly different procedure. We have to actually put more load on the rings to make them bed in quicker. And of course, one of the other reasons why we have to put more load on them is because it's a smaller ring pack, which we know makes more power. So those are the basic differences, but the basic process of breaking in an engine is the same no matter what type of motor.
And the thing is, like what Don's talking about, putting more load in the motor to allow the ring to break in the cylinder, really what you're doing is, you know, Manny's got the hone right back there, and he's getting it honed in, but it's not finished yet. The key to finishing the surface finish is the ring break-in. It's going to knock those peaks off.
The ring's rubbing on the cylinder wall itself in combination with the correct lubricant.
Yep, that whole combination he just mentioned is what smooths the surface and allows the rings to mate up, to bed in to the cylinder wall to create the ring seal you're after. So that's a key part of this process. So again, we're testing gas-ported rings today. So what are we doing? We've got to do a ring break-in to make sure it's ready to go.
And so right now we're watching the engine, all the particulars of the motor. That we're seeing what the motor is doing right now. So we're trying to do a couple of things. We're controlling the water temperature right here. We want to break this motor into a certain water temperature, as we do the same every time. And we're also watching the oil temperature right here. We are also controlling that oil temperature there too. And a lot of you might say, well, 250 degrees on the oil temp, that's quite hot. But think about this. Remember, in your passenger car, what they don't tell you is that oil temperature will reach that every time you start it up. So what we are trying to do here is simulate what's happening in the real world. And with this machine, we can do that by, if you hands down a little bit, this is my dyno control right here. This is a touch tone screen right here. This will stop and start our automatic runs. But these two knobs are really, really important right here. This, we used to have a throttle right here that I'd go like this with, and boy, that was real fun, especially when you're trying to blow a motor up. We've gotten over that now. All we have is a dial right now. And the same thing with the load. This is my throttle right here, and then this is my load control right here. I can manually control both with those right there. And then when I get ready to actually do some dyno pulls, which we're going to do after we finish the break-in process, we'll let the computer take over and do all the work.
Okay, so compared to our run yesterday with the 16th standard package, and today, we got a little bit of a difference in oil temperature. So the oil today is running a little bit cooler than yesterday. A big part of that is that this has got a little bit different ring tension, a little lower ring tension package. So while the water temperature is the same, oil temperature is a little bit different. So we're going to do a little manipulation right now. We just unhook the fan, and we cranked up the load. We're still putting in fresh water to try to keep the water temperature the same, but drive that oil temperature back up to get it more even, to have a fair comparison. So, because right now, we're not really fair on oil temperature, so it's not really fair to say there's any power difference, because we know that the oil temperature difference is not, or there is a difference between an oil temperature. All right. Ready to give it another go?
I'm ready to go here.
So now,
is that water or oil right there?
That is oil.
Okay.
So we got our oil temperature spot on the same. So we're going to come over here and we're going to hit OK and apply. So water temperature is almost the same. So okay, there is a little bit of a power difference with that ring package compared to the standard ring package. A little bit of gain right there around peak torque, and as RPM increases, it's a smaller gain, but it's still there. So back to what we talked about yesterday. We had a plan, we worked the plan, we've not looked at the data until we got completed with every run.
That's 4 foot-pounds.
4 foot-pounds, okay. By making that ring tension and adding the gas ports, and we know that water temperature-wise, we're right on the money. So we got a good, fair test by getting it done.
You just made me laugh again. Lake just says, well, I'll let you do what you do best. And I'm like, what, shut the motor off? That's like one of the easiest things to do, but it's a very simple process. All I'm going to do is basically bring the throttle back down. Back down to an idle, and we still have a little bit of load on there, and you know what? I'm going to keep that load up. Not only that, but I'm going to turn this load up, and I'll tell you why in just a second. I want that motor loaded down, and then I'm going to hit the ignition button just like that and turn it off. And the reason why I do it that way, this is a gasoline motor. The compression is just a little bit on the high side. We got a little bit of timing in it that maybe we wouldn't have if we were racing the thing. We do all those things on purpose, but because of that, the chances of after-run pre-ignition, detonation, whatever you want to call it, is very high. So when I shut one of these gas motors off, I always bring the throttle down. I'll increase the load on it so that the dyno itself helps stop the engine from running. And that's just the easiest way to shut off one of these gasoline motors.
We're back live here at the Engine Performance Expo, and how cool is that? To watch a couple of guys in the dyno room just making rip after rip, run after run. You don't go to work, my friend. You get to have,
I don't.
You get to have a lot of fun.
I'm outed, so all my family that's watching this,
He doesn't.
now they know.
It's not a job.
It's not a job. I go play, and the cool thing is, I get to play with my buddy. I mean, Dyno Don up there. Yeah, as you can tell from watching the video, me and him get along really well. We've done a lot of work together, had tons of fun, and hopefully I think there's lots of good questions coming out of that. I think we started up a little bit.
Well, it is. I want to remind everybody, we're coming down the home stretch here. We're going to do a little Q&A, so get your questions into the comments section. But also, we're going to have a round table after this where we kind of get everybody together and just have a final thought conversation. And then at the conclusion of today, not long from now, we'll be announcing the big winner. That's right.
In my pocket now.
He knows, you know already.
I know.
I don't know.
Lips are sealed.
Exactly. Don, what's it like working with Lake before we get into the Q&A?
Well, you know, it's really been a pleasure over the last 12 years or so. You know, you guys just hit on it. It's not like work. When Lake comes into town and we get to do some testing, we actually have fun doing it. We've got our routines, we've got our set, our set things that we do to make sure that the testing goes the correct way. But the nice part about it is that Lake and I have such a good relationship that we have fun doing it. We're laughing, we're joking the whole time. At the same time that we're learning so much, and again over the last 12 years, it's amazing how much I've personally learned about oils, about rings, just from working with Lake. It's really been a pleasure.
Excellent.
And they've told me everything about motors. Man, I tell everybody, my second group is the Shaver family. That Shaver Racing Engines is where I was able to take theoretical knowledge and get my hands dirty and bust some knuckles and do all that. And Don and Ron and Dennis and Keith and Craig, everybody, Dan, everybody out there has been a huge mentor to me, so I can't thank them enough for everything.
Excellent, excellent. Well, we got some questions. We're on the home stretch. You ready to dive in?
Tee it up. Let's go.
All right. So, and coming out of a little over an hour of you guys in the dyno room, so people are fired up. For instance, Randy Larson wants to know, are you going to mount a temperature sensor on the oil filter for your next dyno runs from now on?
So, hey, Randy, good to see you, buddy. So, no, we're just not going to put 16th, 3/16 rings in our engine anymore because it makes too daggone much temperature. That's the real simple answer.
There you go. There you go. Bill says, with extra oil, did you see oil?
Well, the interesting thing.
Go ahead. Go ahead, Don.
I was just going to say, as far as the temperature sender thing, where our temperature sender is on the engine is actually right next to the oil filter. So we're actually, when this whole thing happened with the crinkling of the label on the oil filter, we were actually able to see it on the computer screen, the added temperature.
So the answer is yes.
Yeah.
They had a premonition. All right, next one. With extra oil, did you guys see oil pressure drop at high RPM?
Yes. I'm not sure. Maybe not have seen it on the video, but that was the biggest thing we saw. And Don and I have seen this over before. And of course, he's busted me, I don't know, numerous times for overfilling it in the old days when we were first doing it. That you could see, wait, as you're making that sweep, all of a sudden oil pressure drops off at the top. And he would say, hey, Lake, you overfilled the oil. Go back in there. Because, when you're running around changing, and there were some days we would do 4 different cam swaps in one day. So we're busting our tails, run. And it's so easy when you're going fast, just dump a cord in, dump a cord in, dump a cord in, dump a cord in, pull the dipstick. Yep, that's good. Shove it back in. By the time that oil makes its way to the bottom, oil level goes too high, and the telltale on the dyno was watching that oil pressure. He'd go, yep, go drain some out. Go back in there and drain it out because he didn't want to affect the test. So, yes, we saw that.
And why is that?
Oh, so as that oil level goes up higher, the crank can hit it easier. So we're talking about in this video is a stroker engine. I know there's lots of questions about how do you determine the proper oil level and all of that. And obviously, the easiest thing to do is to measure from the bottom of the oil pan up to the where the crank is, right? And then you need to know that, okay, from the bottom of that throw to the up, that's your maximum fill level. And then you would need to take the pan out and then fill it to that level to know that that's the practical way of doing it. Now, what we've done is we kind of know that, okay, for a 7-quart oil pan with a 383 stroker with a little bit more stroke to it, then we just kind of use that oil pressure gauge as our telltale. And we just pull a half a quart out at a time until the oil pressure gauge calms down and goes from there. We've never gone through taking it off and measuring it and all that, because I just relied on Don and their wisdom to say, hey, do it the easy way, just watch the gauge. The gauge will tell you everything. Right, Don?
Yes, and the reason, I think we went over this in the recorded video. The reason why the oil pressure will go down is because as that crankshaft hits the oil, that is going down and actually hitting the oil, it's actually starting to try to foam the oil. And when that happens, the oil becomes so aerated, there's so much air in that oil that the air makes its way down to the pickup where it's actually going into the motor. And so you're not, at that particular point, the reason why the oil pressure is going down is because you're not just pumping oil, you're starting to pump a little air also, and that's really not a good thing.
And air is compressible, which is why the oil pressure drops.
Bad thing. Overfilling oil, putting more oil isn't better. It is worse.
That's correct.
It is worse. Okay, Scott wants to know, this one initially at Lake, but obviously both of you guys, don't the thicker rings by themselves, regardless of friction, offer a larger heat transfer area out to the engine, a multiplier effect that cased to engine to gain more heat, overheat, is what it...
Okay, so I see Scott's point. Obviously, I talked to a couple of different piston manufacturers about this. And the reality is, okay, yes, the ring is a conductor of heat, just like Pat Musey was saying.
Yes.
You got all this heat from the combustion event, and it does transfer out through the rings to the cylinder wall to the water. But the thing is, it's not the only way heat gets out of the piston. And in this case, okay, maybe a good example is I'm going to use some gauge on wire. That if you've got a 16 gauge wire and you're only moving X amount of energy through it, it's only going to get so hot. But if you have a much smaller wire with the same energy, it's going to get a lot hotter. Okay, that's an energy transfer thing. So there is a threshold there that, again, too much, too little. I think we said it how many times this week? The word balance. So yes, a 16th, 16th, 3/16 ring gives you more conductivity, but what we saw in this test is that the increase in friction due to that rubbing. I talked about before in the video, maybe I didn't do it in that video, actually, another video. We did a couple of videos that week about this. That if I take my fingers and rub them like this, I don't generate a whole lot of heat or a whole lot of friction. But if I rub my hands like this, I instantly generate more heat, more friction. The reason the water temperature and the oil temperature went up is due to friction, because the constant in all of this between the previous ring set and the 16th ring set is we had the same fuel, same compression ratio, same timing, same speed, same load. The only variable was the thickness of the ring. So it's pretty conclusive that the extra friction generated by the tension and the size of the ring is what generated the excess heat. Don, you can elaborate if you want to. I know I'm kind of opinionated on that.
Well, that was a very good explanation. And what I wanted to add is that the theoretically the piston itself is not supposed to be the piston skirts are not supposed to be touching the cylinder wall. As we all know, that happens all the time. But a lot of the heat that is generated by the combustion temperature, by the combustion explosion, is taken out of the piston by the actual oil itself, by the oil that's hitting the backside of that piston. On a stock engine, because you've got so much oil slinging around everywhere, the oil is always going to hit the backside of that piston, and that's where a lot of the heat from the piston is dissipated, along with the skirts itself. Now, for example, on some of our sprint car engines, especially the new Ford engine that we're working on, we are, and of course the cup guys and a lot of guys have been doing this for years and years and years. We actually have we are actually squirting, purposefully squirting oil on the back side of the piston to take the heat out of the head, the top of the piston. And by doing so, especially on some of our sprint car engines where we're generating so much heat, we can actually lean the engine down a little bit more. We can actually add a little bit more timing because we're trying to take the heat out of the piston with the oil. Thus, we are able to stretch the edge a little bit farther because we are cooling the piston down. Now, if we didn't do that, what happens is the piston will actually get too hot. If it's too lean, if there's too much timing, the piston will actually get too hot, and it literally, because of the temperature, combustion temperature itself, you can melt a piston, and I've done it before, you can melt a piston out of a motor in about 4 seconds.
Right. No, it's a great example, John. We talked about it earlier in the week when the milling guys were here. But it's good to remember that oil isn't just a lubricant. It cleans, it cools, it transfers power. It does more than one job. And in this case, like Don's talking about, it's really important when you have that high compression engine, like we were talking about the director injection engines, DI engines, especially turbocharged DI engines, that extra heat that's generated, you cool it down, not by the water system, oil. That oil squirter on the piston, on the underside of the piston, big deal.
All right, we're going to keep on going with the questions, try to get a couple more here as we are at the end. For those of you who want to know who won the short block, it's going to be the very last thing we do. We're going to draw the name after the round table. Stick around, will not be long. Stick with us. And of course, thank you so much for your interest. And to everybody involved, getting a lot of kudos from people out there on the web. Loving this. And yes, we're going to repost everything. It is all going to be available for you as long as the electricity stays on in our world.
Yeah, exactly. The future consumption is pretty much guaranteed.
Okay, Scott wants to know, the oil filter was empty when it was cut open. He assumes, it was tipped over and drained. Doesn't that risk dumping out all the telltale debris? What is your feeling about filter magnet type devices?
Don, take that one.
You know, that is an excellent question. One of the filter that we use, this is the Wix filter, the Napa filter, brand filter we use. First of all, the filter that's on the engine is basically on the engine with the opening of the filter facing up and the bottom of the filter facing down. Now, that's not the case with all motors. For example, on our sprint car motors, the oil filter's in sideways. But on this particular motor, the oil filter's on like this. So when we cut that oil filter open, I'm going to take the guts out of it. I got a little pail right next, a little bucket I always use for this, and I'm going to stick the filter element in there to let it drain so I can see what's in the filter element. And then I will take the can, and because the contaminants are always going to be heavier than the oil, the big cans anyway, I'm going to slowly pour that oil out into the can to the point where, not all of it, but to the point where I can actually see the bottom of the can. And if there is debris in that filter, that's when I will be able to see it. So again, very good question. Now, when you talk about filter magnets, gosh, that is an incredibly good idea. And not just for the filter, but you know, for most wet sump applications, for example, you know, they make drain plugs with a magnet in them. That is an excellent idea. Now, what a lot of folks don't know is that the filter we use, and I don't know whether Wix does this on purpose or not, but if you actually there's a spring on the bottom of the filter element itself that helps keep that filter element in place. That spring that's between the bottom of the can and the filter element is actually magnetic. On the I don't know if it's that way on all filters, but I know on every Wix filter that I've cut off, it's magnetic. If you take a field strength indicator, which I think I video of that to Lake at one point, it is actually a magnet, and sometimes you will actually see on that spring itself.
All right, next up, for Lake on oil testing, can you name that company of the oil test company that your Porsche buddy discussed, the one that picked up on what he was saying about silicone?
Yeah, so Speed Diagnostics, stay tuned. After this segment, we actually have a little tech tip from Speed Diagnostics. But back to Scott's question about pouring out the telltale information. Well, if you pour that into your oil sample bottle, it can show you all the stuff that you can't see with your eye. But the Speed Diagnostics tech tip will touch on that. Next question.
All right, all right. Next up, how come on, well, this is an interesting question. How come on my dyno I do correction for the amount of humidity, yet cars with EFI don't have a sensor to measure humidity?
Well, I believe on EFI systems, and Ben Strader is a way better guy to answer this question than me, they're looking at mass airflow. So they're able to somewhat correct for that. So I think that's the same kind of thing, is that I know the drag racer guys, I think about the Pattersons and the Stennetts. You know, Gary Stennett's a great guy that has detailed notes about all the air temperature variables. Right. I mean, Don, you have the weather station in the dyno cell as well. So talk about that.
Correct. Well, you know, the Black Widow Superflow dyno that I use, it's just an incredible dyno. It does so much, and it actually comes with its own weather station. So the weather station is always plugged in right very close to the motor, very close to the air that's coming into the engine, so that I can get some accurate readings. And the weather conditions are extremely critical, especially on some of our sprint car stuff, because on the sprint car engine, a sprint car fuel system is stupid. It doesn't correct for temperature or pressure conditions. It doesn't correct for any of that. So you have to know exactly what the weather is to be able to fuel the engine. Now, when I first started at the shop, the computer technology wasn't as good as it is now. I guess that's dating me a little bit, but we actually used to have charts. We had charts that were mounted on the wall next to the dyno, so that we would manually take the temperature, pressure, and humidity factors externally, and then take the number that we from the dyno, and then we would correct based on the charts that we had next to the dyno. Man, it was a tough process. I mean, it took forever, and it wasn't very accurate. But luckily, all the new systems, all the new dyno systems come with a weather station built in, and it just really makes life so much easier.
Oh, no doubt, no doubt.
All right, couple more minutes. Going to try to rapid fire a little bit, because everybody knows we're going to be giving away the motor, so they're all logging back on again. Adam wants to know, and I'm sure you guys discussed it, but maybe hit on it again. What is the best way to break in an engine if you do not have access to a dyno?
Okay, so we actually did a video on that with Ben Strader and Keith Jones that we will actually have kind of a bonus feature that we will release at a later date that answers that question specifically, because we can't answer that in the time we got left.
Wow. But wait, there's more.
Exactly.
What about this one? What's better, upsweep or downsweep, and why when dyno testing?
Don, that's your area of excellence.
Well, we all do an acceleration sweep starting from low RPM to high RPM. We can do it either way, but the difference is that when you're starting at the low RPM and then allowing the dyno itself to release the loader so that the engine will increase in RPM, versus you get a certain number. Now, if you're doing the opposite sweep where you're starting at a high RPM and dragging the engine down, you got to remember that is going to change the force on that load cell. It's going to be greater when you go from high to low, when you're actually trying to stop the motor on the dyno. So, and of course, again, most of the good dynos will compensate for that. But we have always done the acceleration test from a lower RPM to a higher RPM, and the computer itself does all the corrections for us.
Other thing too is, in most cars, what you're trying to do is accelerate the car, which is why there are some dynos that allow the engine to freely accelerate, so you can actually measure the acceleration time. At the end of the day, that's what moves the car.
And there you have it. Great job, guys. That's going to do it for this Q&A. Don, thank you very much. It was great. Learned so much about dyno testing. There is a right way to do it, and we just learned a whole lot. And I got to say, everybody out there who submitted a question, thank you very much. Sorry we couldn't get to all of them, but a lot of them were very similar. But the thing that probably stood out the most was everybody just super excited about the information they received over the course of the last 3 days. So Don, thank you very much. Really appreciate it. To all you guys out there, thank you very much. And on behalf of the audience, thanks to Lake and the team here at the end.
Thanks for having me.
Expo. Awesome stuff. Thank you, Don.
Thanks, Don.
And now we're coming down the home stretch. We're going to have a roundtable discussion in a few minutes. But first, people were just wondering about where they can send their oil to be diagnosed to find out a little bit more information.
Yes, sir.
We know exactly where.
Hi, I'm Lake Speed Jr., Total Seal Piston Rings, but I'm here today to talk to you about something that's not a piston ring. We're going to talk about oil analysis, specifically a SPEEDiagnostix oil analysis kit. You know, as an oil guy in my previous life before coming to Total Seal, I can tell you that contamination is the #1 issue with your motor oil. Your oil is going to do the job it's designed to do unless it gets contaminated. And contamination can come from a couple of things. It can come from fuel, it can come from coolant leaks, but also the wear metal. Your engine is telling you if it's happy or unhappy. You just have to listen to it. The best way to listen to it is via used oil analysis. Just like going to the doctor and having your blood taken, they can analyze your blood to know what's going on inside your body. Used oil analysis, the same thing. It can analyze the health of your engine by taking a sample. And it is super easy. And that's the great thing about the SPEEDiagnostix kit, is that these kits literally come with everything you need, complete prepaid, to take the sample, send it back to the lab, and get a report back that's actually written in English and color-coded, so you don't need to be a tribologist to read it and understand it. So the basic kit actually has, the starter kit I should say, actually comes with a sample pump, so you don't even have to change your oil to take a sample. You can take the sample straight from your engine without having to do an oil change, but also, it also comes with a prepaid mailer. So all you have to do is take your sample, either via drain or take it for the sample pump, take this kit, the sample, put it inside the mailer, drop it in the U.S. mail, already prepaid, pre-addressed, drop it in the mail, off it goes. You'll fill out the information online. There's an online sample submission form. Every SPEEDiagnostix kit has a unique ID number. That way the sample lab and you know exactly which sample you sent, because if you've got more than one car, or maybe you want to sample your engine, transmission, gears, whatever that's got oil in it can be analyzed. You can take that sample, send it in, follow the easy instructions for the online submission form, and then you get back that report. Again, the report is color-coded. If it's green, it means you're good to go. If it's yellow, it means you're still within the normal range, but you're getting near the edge. It's kind of like the rumble strips on the highway. You're not off the road yet, but you're getting pretty close. Then, if it's red, then you know, woo, we've got a problem. We need to investigate, dig deeper to find out what's going on. Because again, going back to what I said at the very beginning, contamination is the #1 reason for engines to fail. More often than not, it's not a parts defect issue, it's contamination. I can tell you from my experience, from working at Joe Gibbs Racing, working at Driven, now working at Total Seal, the #1 reason for an engine to be worn out typically is overfueling. So by using the SPEEDiagnostix kit with the gas chromatography, we can determine the exact amount of fuel in your engine. Based on that, we can know whether or not the wear that's occurring in your engine is from overfueling, which means you can extend the life of your engine, which saves you big money just by doing used oil analysis. So let me tell you a little story about a real world experience. At Joe Gibbs Racing, because they've gone to the NASCAR Truck Series spec motor, that engine cannot be rebuilt between races. It can't even be inspected internally between races. They went to the SPEEDiagnostix oil analysis kit and were actually able to save engines that would have failed in the next race just by determining it via the used oil analysis. One race, not only is it what could save you a win, but it can also save you a championship, which it did for them. So a little bit of money up front to do the analysis can save you big money long term. So that's the reason to do used oil analysis, and SPEEDiagnostik's makes it easy. Thanks for watching.